your study guide on the critical systems that keep our world safe from chemical hazards. From huge industrial plants to the trucks and trains moving through our neighborhoods, there's this invisible architecture of safety and security that's always at work. Today, we're going to pull back the curtain on it. Okay, let's dive in. Here's what we've got on the docket. First, we'll look at the incredibly high stakes to really understand why this matters so much. Then, we'll get the fundamental language of risk down pat. After that, we'll see how these complex safety systems are actually built, and then add a whole other layer, the security dimension. And we'll wrap it all up with a quick review of the key terms you'll want to have in your back pocket. So let's start with the big question. Why do we need these incredibly detailed, sometimes kind of complicated, management systems? Well, because when things go wrong with hazardous chemicals, they can go catastrophically wrong.
And trust me, this is not just some abstract idea. Look at what happened in Graniteville, South Carolina back in 2005. A single, simple mistake, an improperly laid switch, caused a train to derail. That derailment released a massive cloud of chlorine gas. The result was just devastating. 9 people died, hundreds were injured, and thousands had to be evacuated from their homes. This is exactly what we're talking about, and it's the kind of disaster these systems are designed to prevent.
Okay, so to stop something like Graniteville from ever happening again, everyone involved has to be on the same page. We have to speak the same language of risk. So let's break down the core concepts, the absolute bedrock of any safety analysis. Everything, and I mean everything, starts with the hazard. A hazard is just something that has the potential to cause harm. It's the inherent danger sitting there. In the Graniteville case, the hazard was pretty clear. 90 tons of incredibly toxic chlorine gas. Next up is consequence. This answers the question, okay, if we lose control of that hazard, how bad is it going to be? And for Graniteville, the consequence was tragically real. The deaths, the hundreds of injuries, and the complete upending of an entire town. And the final piece of the puzzle is likelihood. This is all, though, probability. How often can we expect something bad to happen? In this case, a single human error, that improperly set switch, made the likelihood of a derailment right there, right then, much, much higher. So when you put it all together, risk is really just the combination of that devastating consequence and the likelihood of it actually happening. Now here's a super important point we have to get straight. Safety and security are not the same thing. Safety is all about preventing accidents, things like equipment breaking down or the kind of human error we saw in Graniteville. Security, on the other hand, is about preventing intentional acts. We're talking sabotage, terrorism, a completely different ballgame that requires a completely different mindset. So now that we have those basic terms down, how do organizations take these ideas and build an actual working system to manage risk? It's way more than just a simple checklist, believe me. It's a whole framework. One of the main frameworks is called Process Safety Management, or PSM for short. You should think of this as a whole operating system for safety. It covers everything from the initial design of a facility to how people work there every day to how equipment is maintained. The most important thing to remember about PSM is that it's not just a book of rules, it's a deep-seated culture of safety. And this is just a brilliant way to visualize how safety really works. You see those huge catastrophic accidents at the top? They're just the tip of the iceberg. They don't just happen out of nowhere. They're almost always the final result of much deeper failures within an organization. See, it all starts at the very bottom with culture. A healthy safety culture shapes people's attitudes and behaviors for the better. Those good behaviors, in turn, make sure the management systems work properly. And strong systems are what catch the precursors, the close calls, the near misses, before they can snowball into incidents, or worse, full-blown accidents. You have to build safety from the ground up. Which brings us to another crucial point. A safety system is never really done. It's a living, breathing process of continuous improvement. It's often called the plan, do, check, act cycle. You plan what you're going to do. You do it. You check your results to see if it's working. And then you act on what you've learned to make the whole system even better. It's a constant loop. All right, so far we've been focused completely on accidents. But in today's world, any solid risk management plan has to think about another, much more deliberate kind of threat. This one question just changes the entire game. Suddenly, we're not just trying to prevent systems from failing. We're actively trying to protect them from a deliberate attack. We're shifting from defending against bad luck to defending against bad intentions. Because in the world of security, you have to account for the adversary. And unlike a piece of failing equipment, an adversary thinks, they plan, they adapt. They're actively looking for weaknesses they can exploit. And understanding their motives is the first step to building a solid defense. So, how does an adversary pick a target? Well, it's a pretty cold calculation. You have to try to think like they do. They're looking for targets that give them the biggest bang for their buck. Things that could cause mass casualties, create massive economic disruption, or just grab a ton of media headlines. And of course, the easier it is to get to a target, the more attractive it becomes. So to counter that kind of threat, you can't just sit back and hope for the best. Organizations use a process called a Transportation Security Vulnerability Analysis, or a TSVA. This is all about proactively thinking like an adversary to find your own weaknesses and then fixing them before anyone else can find them. All right, to finish up our session today, let's switch into full-on study guide mode. We're going to do a quick flashcard review of the biggest terms and concepts we've covered. These are the ones you'll definitely want to know. First up, PSM, or Process Safety Management. Remember, this is that huge, comprehensive system we talked about. It's the whole framework designed to prevent catastrophic, accidental releases. It's really the foundation of modern industrial safety. Next on our list is QRA, which stands for Quantitative Risk Analysis. This is the deep dive, super data-heavy approach. You use a QRA when just saying a risk is high or low isn't enough. You need an actual number. It takes a lot of work, but it gives you an incredibly precise picture of your risk. BLIV. Now this one stands for Boiling Liquid Expanding Vapor Explosion, and it is every bit as terrifying as it sounds. It's what happens when a pressurized tank of liquid gets caught in a fire and ruptures, creating a massive, instantaneous fireball. It is the absolute nightmare scenario that safety systems are built to prevent at all costs. And our last term is RAGAGIP. I know it's a mouthful, but the concept is actually pretty simple. It stands for Recognized and Generally Accepted Good Engineering Practices. Just think of these as the official rule books for engineers, the industry standards that say exactly how a valve, a pipe, or a tank needs to be designed, built, and maintained to be safe. They're the technical backbone of the whole system. So we'll end with a thought for you to chew on. These huge, complex systems of safety and security, they're working all around us, quietly, in the background, every single day. They're in the fuel in your car, the products you buy, the infrastructure you rely on. So where do you see their impact in your daily life? Something to think about.